Hello again, everyone. This is Mr. B. Hill. Today we're going to be talking about simplifying algebraic expressions. And so first, just to remind ourselves what the word simplify means. Of course, we've talked about this a lot in class. To simplify means to do all the arithmetic you can. And now we've actually talked about a few things, so we can do more arithmetic than we used to be able to. For instance, we can combine all the like terms in an expression. We can combine all the like factors in an expression, meaning if you can add things together, you do, and if you can multiply things together, you do that too. Also, we're going to apply the distributive properties to eliminate any parentheses. If there's parentheses in the expression, then we can do more simplifying with that. And so to illustrate this and show you kind of how this works, we're just going to work through a pretty big example here. This one right here, we have 2x, which is being raised to the power of 2, you're squaring it, plus 7x times the quantity x minus 3, plus 5x times the quantity 4x plus 2x. Now, it seems a little big right now, but if we deal with this step by step and chunk it out pretty well, it's not really all that difficult. So the first thing that I always do, just because, well, I hate the operation of subtraction because it's really unnecessary. Subtraction is actually adding the negative, so just to not get confused and to not lose any negative signs in here, I'm going to change this subtraction to an addition. So subtracting 3 is the same thing as adding negative 3, so I'm just going to work below here. So this whole expression is now equal to, and we're going to keep everything else the same, and we're only going to change this one little subtraction sign here. Baby steps through this thing. So we've got 2x squared plus 7x times the quantity x, and just to show you what I'm doing different here, switching that subtracting 3 to adding negative 3. Hopefully that shows up on your screen. That's in red, the change that I made. Plus 5x times the quantity 4x plus 2x. There we go. So that's the only thing that we changed right there. And the reason why we could do that is, well, that's just the definition of subtraction. And so it's a good idea to record why you can do the changes that you did, so you can go back and make sure you did everything right, showing your work. You're communicating to yourself what you're doing and how you understand this. So now let's do a little bit more. Now, there's a lot of different ways you can do this, really, orders in which you do the simplification. You can just deal with each term in here separately, but just for a goof, I'm just going to follow the order of operations, just because that's never a bad idea. You can't go wrong with it. And so, first off, we need to deal with what's inside the parentheses first. And so, we see here, well, here's some parentheses, and inside there we've got 2 times x. Well, we can't do that multiplication because we don't know what x is. Over here in these parentheses, we've got x plus negative 3. We can't do that addition yet because we don't know what x is. And over here inside these parentheses, we've got 4x plus 2x. Oh, wait a second. Yes, we actually can do this addition because these are like terms. So we'll just do this addition in here. 4x plus 2x is, of course, 6x. So everything else is going to stay the same. 2x squared plus 7x times x plus negative 3 plus 5x times, now 4x plus 2x is 6x. The reason we can do that is just combining like terms. No big deal. Now we could keep working within this term over here, the 5x times the 6x, if we felt like it, but let's go back and just follow the order of operations again. Now we can't do what's inside these parentheses because we don't know what x is again, so that's just 6x. So the next thing we're going to do is the actual exponent here. And the way we're going to deal with that is we have a product being raised to a power. So remember, exponents distribute over multiplication. So we can take this exponent of 2 here and we can distribute it to each of the factors inside the parentheses there. So 2 squared is going to be 4. I'm going to combine a couple steps here and actually do that combining like factors. Then we have x, which is being squared now, because 2x times 2x, the 2 times 2 is 4, x times x is x squared, no big deal. And now everything else is just going to stay the same. 7x times the quantity x plus negative 3 plus 5x times 6x. And I call that the distributive property for exponents. And then we also did a little bit of combining like factors in there too, with the 2 times 2 as being 4. Often you hear this called the product to a power rule. Where if you have a product being raised to a power, then each of the factors gets raised to that power. I like to call it distributive property for exponents because really it's just an extension of the distributive property. Next, let's see here, what have we got? So we did that exponent. The next thing we're going to deal with is multiplications. So we've got some multiplications over here, but we also have a multiplication here. Can't do 7 times x. And so really, we've got this factor 7 times x, which is being multiplied by this sum in here. And so we can distribute the 7x to each of those terms. And we're doing that because the next thing to deal with is multiplication. We can't do the multiplication here because we don't know what x is. So now we're going to do the multiplication by applying the distributive property. That's how you do that multiplication. And so everything else is going to stay the same. We've got 4x squared plus this factor of 7x times x plus the factor of 7x times negative 3 plus, we didn't do anything to this last term, 5x times 6x. And so that was just an application of the distributive property. And that's just your basic distributive property, in that multiplication distributes over addition. And now, we've still got a bunch of multiplications to deal with now. We've got this one in here, this one in here, and this one over here. And notice here, in each of these terms, the only thing happening is multiplication. 7 times x times another x. 7 times x times negative 3, 5 times x times 6 times x. And so since within each of these 3 terms, the only thing that's happening is multiplication, these parentheses that we have in here don't actually mean anything because of the associative property. So we can just drop those things. So we have still 4x squared in that first term, plus 7 times x plus 7 times x times negative 3, plus 5 times x times 6 times x. We can drop those parentheses, again, because of the associative property. Specifically the associative property of multiplication, but both addition and multiplication are associative, so I'm just not even going to put it in there. You might want to yourself. Next, what we have is we have to do the multiplications that we can. And so we have an x times x here in this term, so that we can rewrite as, we're just going to change this, x times x we know is x squared, so this is 4x squared, leave that alone, plus 7 times x squared, plus, leave everything else alone, 7 times x times negative 3, plus 5 times x times 6 times x. And there we're just combining the like factors of x and x into x squared. Next, we've got some multiplications over here. And we actually, within this term, we've got like factors of 7 and negative 3. They're both constants. We can multiply them together. Over here, we've got a 5 and a 6, like factors, but also an x and an x. But first, we need to get those like factors together within those terms. So we're going to apply the commutative property there. This first term, we're leaving that alone, 4 times x squared. Second term, that's one's done, 7x squared. Plus, we're going to rearrange this, so this is 7 times negative 3 times x. We're just reversing the order of these two factors. Plus 5 times 6 times x times x. Just rearrange the order of the x and the 6 in that term. And that is, of course, the commutative property. And specifically the commutative property of multiplication. But again, both operations, addition and multiplication, are commutative. And also not the commutative property, commutative. See too many kids calling that the commutative property. Nothing's communing here. We've got one factor commuting to the other side of it, of the other one. And now we can combine some like factors here. We know what 7 times negative 3 is, we know what 5 times 6 is, and we know what x times x is. So we have 4x squared plus 7x squared plus negative 21x plus 5 times 6 is 30, and x times x is x squared. So there we just combine some like factors. Now we see that we have 3 like terms in here. So in order to get these like terms together, we're going to have to switch the order of these two terms, again by applying the commutative property, this time of addition. So this is 4x squared plus 7x squared plus 30x squared plus negative 21x. Applying the commutative property. And then finally, we can combine these 3 like terms. We have 4 of these x squareds plus 7 more of these x squareds plus 30 of these x squareds, making a total of 41 x squareds plus this last term here, negative 21x. And there we just combined the like terms. And now we have done all of the arithmetic that we can. We can't combine these two terms because they're not like terms. This is x squared, this is just x. We could switch this adding negative 21x back to a subtraction, but it's actually not necessary. This is perfectly fine by me. And that's basically it. Now we have no parentheses in here. We can't do any more distributive properties or anything like that. This is completely simplified. So, I'm going to leave you guys with a couple of practice problems right here. A little bit simpler ones, but work through these and just go through step by tedious, laborious step. You probably want to write down why you can do what you're doing in each step, and a little practice for you. So, go do those. No, seriously, go do them. Get some practice. Go do these problems. Simplify these things. I'll see you in class.